Okay, so we're going to look at some water questions now. So the first one is a question that appears in section A, question 1, and it's a titration question that uses edta and a sample of water. The sample of water can often come from a river or any sort of water source. And what we're doing is we're testing out the hardness of the water. So if you want to pause and just give a quick read through the question first, and we're going to be focusing on the calculation side of the question, so part E. Okay, so hopefully you've that read now. Okay, so let's just look at the equation then. So it says in the question that this m+2 represents the ions that are in the water that create the hardness in the first place. Then the edta ions are represented by this one right here. And I'm just going to bring it to note that they react in a 1-to-1 ratio together. So we're going to be using that. Now also, when we're looking at these questions, we should just underline any possible important information. So we've got 50 centimeters cubed of the sample of water. We're reacting that with edta. And we've more information about edta. We've got the molarity of it. And I reacted with 50 centimeters cubed of the water. And the amount of edta needed was 9.3 centimeters cubed. So if I come over here and I just say edta, and I write down all of the information I have about it, I have 0.01 molar of it. And in the titration, the average amount was 9.3 centimeters cubed. Okay. And the only thing we know about the water was that 50 centimeters cubed of it was used. The very first question then is the average number of moles of edta used in the titrations. So again, from a different video, if you looked at first principles, it's asking for the number of moles in a specific amount in the titration. So you're going to use first principles here. So all you have to do with that first one though is you know how much the edta was used in the titration. That's 9.3. Now if I put that over a litre, which is 1,000, and I multiply it by the molarity, I'm going to figure out how many moles of the substance I actually have, which is 9.3 by 10 to the minus 5 moles of edta in the 9.3 centimeters cubed. Okay, just to do a bit more on that, the 0.01 molar is the same as 0.01 moles per litre. Now I don't have a litre, I only have 9.3. So I want a fraction of that. So that's why I'm multiplying this fraction by this here. Because I don't want whatever's in a full litre. So that would be 1,000 over 1,000. I want a fraction of it. Okay, so that's part 1 done. We found out the average number of moles of edta used in the titration. The next one then is the number of moles of the M2 plus ion in 50 centimeters cubed of water. Well, if 9.3 by 10 to the minus 5 moles of edta reacted, and we've already looked that they react in a 1-to-1 ratio, that's how we're going to answer the second one. So our ions in the water that create the hardness react with the edta ions in a 1-to-1 ratio. So that means if we have 9.3 by 10 to the minus 5 moles of edta, that's going to react with the exact same amount of moles of the ions in the water. So just a quick ratio, and we see that it's 9.3 by 10 to the 10 to the minus 5 moles of ms+2 in the 50 centimeters cubed of water. And that's part 2 answered as well. Now the next question, part 3, is asking for the total hardness of the water expressed in grams per litre of calcium carbonate. So it's grams per litre. Now, at the moment, the only thing information that we have about hardness is the amount of this ion in 50 centimeters cubed of water. So we have the number of moles of the ions that creates the hardness in the water. Okay, so I'm just going to write hardness here. I've got 9.3 by 10 to the minus 5 moles, I'm going to say, of the calcium carbonate, because that's the ion that's creating the hardness, in 50 centimeters cubed of water. Okay, so I need to get it up to grams per litre. So if there's that many moles in 50 centimeters cubed, I'm just going to multiply up this number into up to a litre. So there's 20 50 centimeters cubed in a litre. So I'm going to multiply this number by 20 to see how many moles are in a litre of the water. And there's your answer there. So 0.00186 moles per litre of the calcium carbonate. Now it's not asking me for moles, it's asking me for grams. So I'm going to use this equation. Which is number of moles equals mass over relative molecular mass. So the number of moles of the calcium carbonate per litre is here. We want to find out the mass. And then the relative molecular mass is 40 for the calcium, 12 for the carbon, and then 3/16 for the 3 oxygens. So that's going to turn out to be 0.00186 times 100, because all of that adds up to 100, equals the mass. Okay, when we find that out, it's 0.186 grams per litre of the calcium carbonate that's present in our water. Okay, that's the part 3. Now the very last question then asks us about the total hardness of the water expressed as parts per million, which is the same as saying milligrams per litre. So all we have to do is change this grams per litre into milligrams per litre. And to do that, you just move the decimal place to the right 3 hops. So that's going to turn into now 186 milligrams per litre, or 186 parts per million. And that's part E of that question answered. So the next question we're going to look at is a question from your book. It's still focusing on edta and with using parts per million. Okay, so here's a question from your book. If you want to give it a quick read through, we will be focusing on the very last part, part 6, which is the calculation section. Okay, so we have 2 situations. We have a situation where we have the spring water which has been boiled, and then the spring water which has been unboiled. So boiled water, unboiled water. And then we also have the edta that we use in the titrations for each of these. So what I'm going to do is I'm just going to pull out the information for the boiled water. So the volume that was used is 100 centimeters cubed in both of them. Okay, so that's the volume of the water for each of those. And then the edta, we have the molarity of the edta, which is 0.01 molar. And then the edta that's used for the volume of the edta, which is used for the boiled water, is 6 centimeters cubed. And the volume of the edta, which is used for the unboiled water, is 19 centimeters cubed. Okay, and that's the information that's given to us, along with the equation, of course, down here, which is our edta here and our ion reacting in a 1-to-1 ratio. Okay, so we have two titrations happening, and I think we have enough information now to work away with this equation here. The molarity of the EDTA by the volume over the number that's in our chemical equation, with the molarity, the volume, and the number with our water. So we know the molarity of the EDTA, it's 0.01, so I can put that in. The volume of the EDTA used in the boiled water section was 6 centimeters cubed. And our number in the equation is 1. The molarity of the water, we don't know. I suppose I say the molarity of the calcium ion in the water, we don't know. The volume that was used in the titration was 100. And from our equation again, over here, it's a 1. So if I just maneuver that around now, I'll be able to work out the concentration of the calcium ion in the boiled water, which is 0.0006 moles per litre of the calcium 2+ ion in the boiled water. Okay, I'm going to come over here and just do the exact same thing for the unboiled water. This is our starting point. So now we've got the same EDTA used, and we used 19 centimeters cubed this time. Still used 100 centimeters cubed. So now the concentration of the calcium ion in the unboiled water is 0.0019 moles per litre of the calcium in unboiled water. Okay, so at the moment now I have the concentrations of all the calcium in boiled and unboiled. So I'm just going to reread the question there. It says calculate the total hardness of water in the bucket. Now we know the hardness is directly related to the amount of the calcium ion that's in the actual water, but it wants it to be expressed as parts per million of the calcium carbonate. So you need to change this from moles per litre into parts per million. Okay, so to do that we need to first convert to grams. So we're going to use this formula. Number of moles equals mass over relative molecular mass. And it says in terms of calcium carbonate. So our relative molecular mass is going to be calcium carbonate, which is 40 plus 12 plus 3 times 16, which gives us 100. So take the 0.0006 mass over the 100, and we'll find out our mass of the calcium carbonate to be 0.19 grams per litre. Now parts per million, we just need to move the decimal point here 3 jumps, and it'll give us the answer in milligrams per litre, which is 190 milligrams per litre, which converts straight into parts per million, 190 parts per million for the boiled section. So I'm going to do the same thing now over here for the unboiled water. So I'm going to convert that moles per litre into grams per litre using the exact same formula. And still calcium carbonate, of course, so I'm going to use 100. Oh, sorry, I made a little mistake there. This should actually read out to be that 0.006 should have turned into 0.06 grams per litre of the calcium carbonate. And turn that into milligrams, it's going to be 60 milligrams per litre, which is 60 parts per million. And I'll quickly just pause and write in the other side, which you've already seen. Okay, so the question asked, calculate the total hardness of the water in the bucket expressed as parts per million. And total hardness is when we haven't treated it at all. So there is a difference between permanent hardness and temporary hardness. And a way of removing the temporary hardness is by boiling the solution. So the total hardness is when it's unchanged, when it's unaltered, so unboiled. So the very first answer there is your total hardness is 190 parts per million of the calcium carbonate, because we haven't done anything to it. Okay, so when the solution is boiled, the calcium hydrogen carbonate that's present converts into calcium carbonate, carbon dioxide and water. So we're removing some hardness when we're actually boiling the water. And when it's boiled, we found out that there's only 160 parts per million left in the water. So due to the calcium hydrogen carbonate, so the second part, calculate also the hardness that was due to the presence of this calcium hydrogen carbonate. We can just take them away. So this is it, unboiled, 190. That was the level of hardness. Then when we removed the calcium hydrogen carbonate by boiling it, it's now down to 60 parts per million. So 190 take away 60 is 130 parts per million. So the 130 parts per million was all of the hardness that we've removed because we boiled the water. Okay, so the next video we're going to be in water, we're going to be looking at the amount of dissolved oxygen in the water.